To secure a good grade in your IGCSE Physics 625 exam, it is important to clearly explain how the scattering of alpha particles by a thin sheet of metal supports the nuclear model of the atom. Below is a structured response that addresses each point with relevant evidence. Alpha particle scattering experiment. The scattering of alpha particles was famously demonstrated by Ernest Rutherford in his gold foil experiment in 1909. This experiment provided crucial evidence for the nuclear model of the atom, which proposed that atoms consist of a small, dense nucleus surrounded by electrons. Evidence for a very small nucleus surrounded by mostly empty space. Observation: most alpha particles passed straight through the gold foil without any deflection. Interpretation: if the atom were composed of a uniform distribution of positive charge, as suggested by the plum pudding model, we would expect the alpha particles to be deflected at various angles due to interactions with the positive charge. However, the fact that most alpha particles passed through without any deflection indicates that the nucleus is very small compared to the overall size of the atom. Conclusion: this suggests that atoms are mostly empty space, with a tiny nucleus at the center, supporting the nuclear model. B. Evidence for a nucleus containing most of the mass of the atom. Observation: a small fraction of alpha particles were deflected at large angles, and a very few were reflected back. Interpretation: the significant deflections of some alpha particles indicate that they encountered a dense region within the atom. Since alpha particles are relatively massive and positively charged, a strong interaction would only occur if they approached a massive, positively charged center. The fact that only a small number of alpha particles were deflected suggests that the nucleus is small but contains most of the atom's mass. Conclusion: this supports the idea that the nucleus is where most of the mass of the atom is concentrated, as the majority of the atom is empty space. C. Evidence for a nucleus that is positively charged. Observation: the deflection of alpha particles occurred at large angles, and some were even reflected back toward the source. Interpretation: since alpha particles are positively charged, they consist of 2 protons and 2 neutrons, they would experience a repulsive force when approaching another positively charged body. The large-angle deflections and reflections indicate that the nucleus must be positively charged to repel the positively charged alpha particles. Conclusion: this provides evidence that the nucleus is positively charged, as it must exert a strong enough force to cause the observed deflections of the alpha particles. HAPS summary: the scattering of alpha particles by a thin sheet of metal provides compelling evidence for the nuclear model of the atom. 1. Very small nucleus surrounded by mostly empty space. Most alpha particles passed through the foil without deflection, indicating that atoms are mostly empty space with a small nucleus. 2. Nucleus containing most of the mass. The small fraction of alpha particles that were deflected at large angles suggests that the nucleus is dense and contains most of the atom's mass. 3. Positively charged nucleus. The deflection of positively charged alpha particles indicates that the nucleus itself is positively charged, repelling the alpha particles. By clearly articulating these points, you can effectively demonstrate your understanding of the nuclear model of the atom and secure a good grade in your exam.